Confidence Mother. Morning, ladies and gentlemen. Thanks for the opportunity to talk to you today. I'm Dr. Rob Winnell. We'll be talking today in relation to STEM education here at UNE. I'll be talking to four main points. Firstly, I'll talk about what employers say they want from STEM education, what I see as the pillars of STEM education which will provide us with a way forward, and the evolution of STEM education here at UNE over the last few years and how we can move forward into the future. In 2015, Australia's chief scientists produced this graph which summarised what employers say they want from our STEM students. We can see that occupation-specific STEM skills are quite way down the list, below things like problem solving, creative thinking, and being able to learn new skills quickly and on the job in the real world. So we have to consider how we can facilitate the top, the things at the top of this list for our students, as well as the knowledge that they get from specific STEM pursuits. Now, based upon the work that I've done over many years, it's my view that there are three main pillars to STEM education. The first one is that it is education of the real world. It is students engaging with real world problems using whatever skills and tools that they require to understand that world. Secondly, it involves inquiry-based approaches to solve those problems and answer the questions that they have in their own mind. And thirdly, it requires an integrated approach to how they solve and answer questions. A real world problem, even a very simple one, rarely has a solution which lies specifically in one academic domain. So therefore we have to get students understanding what a real world problem is, what things I need to bring to that problem to be able to understand it and solve it, and then to be able to be skilled within those different areas, those academic areas, which will allow that solution to be done. Now, in 2015, Blackley and Howell proposed this series of steps as the way that STEM has evolved here in Australia over the last 15 years. We can see that in the early days, STEM, with the full stops between each of the letters, has been enacted and interpreted as a set of disciplines which are done separately, which don't really cross into each other's domain. In particular, in the third step, you can see that technology and engineering have not rated strongly in the maths and science areas. Where we are now, in my view, is that we now have a new political agenda which is driving a new way of looking at STEM, and it's built around the idea that STEM does not have full stops between each of the disciplines, that they are a set of disciplines that all work hand in hand, and they are integrated together so that students can use whatever tools they require to work in the real world to answer real world problems. So where we need to look to in the future is the teaching and research that enables us to meet that requirement. Now, we've already, over the last few years, done a number of things here in research projects which will provide a foundation for our work in the future in STEM. First one was the digital classroom. This RUN project involved all of the RUN universities and all contributed something to a Moodle site. Now that Moodle site for UNE was based on our smart farm, and what we did was we looked at a cow standing in a field and using RFID technology to know the location of the cow. We introduced students to the idea of what smart farming was, why it was important for our future, and then we looked at this one simple situation of a cow in a paddock and how the farmer can know where that cow is using the technology of today. And we looked at the science involved and the mathematics in two different modules. We've also been involved in it's part of my life project, which is just about to finish. This has been running now for the last 3 years. The idea behind this project was that students, even young students, use everyday mathematics and science thinking as a part of their everyday world. The problem is, though, that when we get them into schools, we leave that behind and we teach them a whole heap of different algorithmic and symbolic approaches to thinking that separates them from that idea that I already know, do math and science thinking. So what the project involved was looking at researching how we can teach in a way that enables them to bring that everyday thinking that they use in their everyday world in inquiry-based approaches to enable them to solve those real-world situations. Now, in this project, we haven't yet looked at how we do that in the two dimensions together. Some universities did science and some did mathematics. So we're at the cusp now of looking at how we bring together the different dimensions of academic pursuit in the one place to solve these problems. If we go to the Smart Farm Learning Hub and look at the agriculture syllabus here in New South Wales, it is particularly oriented to STEM, the STEM way of thinking. And the ag units here are now being redeveloped upon that basis. It's using a lot of the work that we've got already existing, like the work from the digital classroom, and where it's being introduced to the idea for ag teachers, ag science teachers, that they are in fact working as STEM educators. Of course, it's got an A in there for agriculture. So now what we have to think about is how we bring all of this together to go forward from this point in time. We also have to remember that the ETMST suite of projects is just, which It's Part of My Life project is a part of, is just about to finish. These projects involved a number of different universities, and there was $16 million spent. The two red asterisk ones are the ones that I've been very closely involved with. The philosophy behind all of them, the idea for all of them was very, very similar. It was essentially trying to make, to get scientists and mathematicians working with educators to change the way we prepare our pre-service teachers so that they understand the thinking involved in these fields and how we can use that in inquiry-based approaches to solve real-world problems. So what we have to do now is to take the work that has been done here and look at it from the UNE perspective. This is one area of research that's waiting to be done. We have to look at how we can include the new ways of doing our business that has been promoted by these projects and incorporate it into what we do here within the UNE context to really develop our online teaching. Russell Tytler, as recently as December 2, when he was talking in the conversation about how we boost science performance, is also reiterating these sorts of things. What he argues is we have to improve the quality of our teaching. The second thing is that to do that, we have to make our science curriculum more engaging and it better reflects science in the world. Now, this is applicable to any dimension of teaching, whether it be in STEM or otherwise. We have to get our teaching and our pre-service education people working to create a curriculum in their classroom which is situated in the real world, and students are engaging with that real world and using the tools at their disposal to understand it. The last part, he argues, is that we need to align what we do in school with the way science, mathematics, technology works in the real world. So students are engaging with their world and working to understand it. Where we go from here, in my view, is that we already have an established history within the regional universities network. We've been involved in 2 large-scale projects. The relationships already exist for academics from all of these universities. We've been working together for 4 years, and the opportunity continues from next year to gain more funding to further the work that we've already been doing. The 2 things that we haven't yet used as a part of those projects in the education sphere broadly are UNE Vital and the Smart Farm. So what we would hope now is that we can now look to use UNE Vital much more and the Smart Farm much more closely within the teaching that we're going to be doing and changing the practice that we have with our education students. Now, we also have to consider that the focus for STEM education doesn't live within the limits of the university and the production of pre-service teachers who think along an integrated STEM perspective. What we see out in the world at the moment is the primary and secondary school education authorities grappling with the idea of STEM and how we can introduce it into schools. Now, this was a presentation done by the Queensland Curriculum and Assessment Authority on the 29th of November to the leadership team at Bellberg Park State Secondary College. It was trying to get the leadership team to get their head around the idea of what integrated STEM education actually looks like. Before we can get STEM working in schools, we have to be able to answer this question. And so the universities and the researchers there have to work closely with schools so that when our pre-service teachers go to schools, they will meet an environment which is they are able to work within to address this integrated STEM approach. Now, the paper that was used for this, all of the participants were provided with a paper prior to attending the workshop. That paper was based on a paper being presented at a international conference in January that's been written by the presenter, that's John Pedrozzini, who works at ACARA, and myself. The purpose was to provoke a set of some thinking in the participants as to what is it that integrated STEM looks like, what does a school have to look like to be able to pursue an integrated STEM agenda, and what are the requirements, the principal key things that they have to have in place to be able to do that. So that is my view of where STEM education is at the moment and where we'll be moving towards in the future over the next 5 years. Has anybody got any questions?